In this demo, we're going to look at a slightly different approach to automated machine learning, and we're going to use a forecasting problem. And so let me set up the scenario for you. Tailwinds Traders has lots and lots of different stores across the world. And one thing that they've found is a bit of an issue is that in some stores they have all the stock goes really, really quickly and people are actually demanding more. Whereas in some stores, the stock is kind of is staying on the shelves and they can't seem to move it. And both of these things are an issue in both store 1 and store 2. And so what they want to be able to do is they want to be able to forecast correctly how to have the correct products in the correct stores at the correct times. And so one thing that we're going to do now is we're going to try and use our forecasting data on sales to actually predict what are the forecasted sales quantities per item, per store for the next few weeks. And so let me show how we can start to approach this problem. So we're back in our automated machine learning section of the Azure Machine Learning Studio. And this time what we're going to do is we're going to use our forecasting data. And so if I quickly show you what the forecasting data looks like. This is what the forecasting data looks like. So we have our store ID, we have our product ID, we have a date that this different reading was taken. We have a value for the amount of quantity for that store, that product in that store. We also have things like the retail index, as well as information about what time of the year it is. So a lot of seasonality is useful inside forecasting problems. And so this is the data set we're going to use. And the piece we're trying to forecast is the value. How many of product 2 do we need in store 1 on a certain date, given historical data? I have this data set already prepared and uploaded. If I didn't, I could upload it from here or connect from a data store. We can see that the forecasting data set is here, and this is the one that we'll be using. So if I click on Automated Machine Learning, click New Automated Machine Learning Run, and click on our forecasting data set and click Next. We can create a new experiment called Tailwinds Traders Forecasting V2. I can choose my target column, and in this case it was value, and I can choose my compute cluster, which is CPU compute, and click Next. This time, instead of choosing regression, I'm going to use time forecasting. We can see that this one now comes up with different examples and methods, so definitely go to the documentation to find out more about what you can choose in here and why it's useful. So we need to select our time column. Our time column is our date. And then our group by columns. This is columns that define distinct groups in the data which can produce different forecasts based on each group. For example, product names, store locations, or brand names. And so in our case, we said we wanted to forecast per item, per store. And so if we choose our store ID as well as our product ID, it will allow us to group by these. Because as well, if you didn't do this, you actually get an error because our date is duplicated, because each store and each product has the same date reading. And so this is necessary in order for us to run this. The forecast horizon, you can specifically tell it the actual period of data you want it to forecast forward, or you can choose for it to auto detect it. We're going to choose for it auto detect it, and we're not going to use deep learning in this case. However, it's well worth trying it out as you're experimenting. We can click on view additional settings. We can use our normalized root mean squared error. We definitely want to explain our best model again. Something that we don't want it to choose, we could choose this and say don't choose any of these algorithms. Additional forecasting settings, this wasn't in the previous one. We do want to actually use forecast target lags. So feel free to click on learn more and understand target lags, but lag is basically how much of the previous few weeks do we want to take into account for the forecast. So I'm going to click on auto detect. And then you can also do target rolling window size. So again, historical periods that generate new forecasts. And so I'm going to suggest auto detect, but you can put in your specific periods once you understand more about your data problem. Exit criterion, will do the same thing again and choose just 1 hour. Under validation, I'm very, very happy to use cross validation in this case, and also our concurrent iterations, and click save. And then once we're happy, we can click finish. Again, just like it did with the regression problem, it validates our run and it gets started on pre-processing our data, which will turn up under data guardrails, and also reviewing our models. So let's take a look at one that we ran previously. Here is a run that completed based on our sales forecasting. We can see that it took around 32 minutes to run. We can see that the stack ensemble method was the best approach, and its normalized root mean squared error is very good. It's 0.04, so closer to 0 the better, because 0 error would mean it was perfect. That there is also obviously issues with that, but you can also view some of the other metrics to see how that model is doing. And as we know from prior, if we click on the stack ensemble method, we can see more about that specific algorithm, as well as any explanations that are available to us to understand what it is in our model that is driving our model. We can see under data guardrails the type of information that it did, and with forecasting it will do slightly different featurization. So it does frequency detection. It was able to detect the series, so it's per week in our case for our series. It was able to say that there's no missing features and there's no memory issues with the auto lag, horizon and rolling windows. So if they were very, very long in front, there might be memory issues there. We can see that again, it ran lots and lots of different models depending on our specific problem. And I was also able to, if we go back to details and we go to unstock ensemble method, we can see I was actually able to deploy this model. So you can click on the model where it's deployed. We can see our forecasting model, it's in a healthy state. We can see our REST endpoint and our Swagger definition again. So let's take a look at this definition. If I click copy, let me just remove this, paste it in. My favorite trick around this is Alt-Shift-F. We can scroll down, we can see the schema there, and we can also see again the example data. If I now go to Postman and go to my sales forecast, I am able to put in the REST endpoint just here. Under headers, I can see content type, application JSON, and then under body, I can see that I have two different things available to me here, with a date that is newer than the data that is in that is inside the training data. And then when I click send, we can see that it was a status 200. And if I scroll down just here, we can see that it was able to forecast that for store 1 product 2 in January, which isn't in the training data. We can see that it predicts 205 items, and then for store 1 product 2 the week after, it says okay, go slightly down and get 201 items. And we can see here it has the store ID and the product ID, so it could have seen it from here as well. Okay, so we showed there that it was a very, very similar approach. We have a data set, we build our problem, we review our results and the interpretability, we deploy the model, and then we consume it. However, these were two quite different problems, and so it's showing some of the flexibility that you have around solving your machine learning problems using automated machine learning.